This tutorial deals with Archimedes' principle, and Archimedes was a philosopher, a Greek philosopher. He was from Syracuse, and well, the situation here is that he proposed how certain systems float in a fluid, while others are not able to float, and this is due to a force called the buoyant force. Let's imagine we have a tank, for instance, any given tank, and the tank has a fluid. The fluid can be water, can be oil, can be anything. Even air, which is a gas, is considered a fluid. Now let's input any given solid mass inside this fluid, and there will be certain forces that are going to be exerted in this solid, and a free body diagram of this solid will actually state that there are, for instance, its own weight, right, that is going downwards, and there are two more forces. The first force is due to the layers of that are upwards, the layers of this fluid, and that is a pressure times a transverse area that is upwards. While there is another force, for instance, due to the layers that are as well up the down part, and they are pushing upwards, so there is a pressure downwards times the transverse area as well. Now the two forces due to the pressure up and the pressure down, they can be just packed up together, and for instance we have a positive force, which is the pressure down times the transverse area, but we have also a negative, because it's going downwards, force, which is the pressure up times the transverse area. Of course we also have mass times gravity, but these two forces, pressure up and pressure down, or due to the difference of pressures, we can state that they are generating a single force, and we're going to group this force. We know, for instance, that the pressure is due to the density of the fluid times the gravity and times the y, which we have, for instance, in the downwards part, and of course times area, right, because this is a force, minus, and the pressure up, for instance, we have as well a depth in the upward part, so it's the density of the fluid times the gravity times y, which is upwards, times the transverse area. Now there are common terms here, so we can actually factorize these common terms, and we can extract that this is the density of the fluid times gravity times area times y down minus y up, and this difference, y down minus y up, is, for instance, the delta y. So this is density of the fluid, gravity, area, delta y, and area times delta y, this term, for instance, is the volume which is being displaced by the solid object which is submerged in the fluid. So this is density of the fluid, gravity times the volume which is, for instance, displaced. This new force that we have generated, we're going to call it the buoyant force. Of course, it's a vector, it's a buoyant force, and this is the density of the fluid which the object is submerging, the gravity, and times the volume this is displaced. Since the pressure downwards is always higher than the pressure upwards, this means that the buoyant force is being exerted towards the upwards direction, and this is called also the floating force. This is the reason why things float in any given fluid. So for the object that is submerged, we can actually state that there are two forces. The first one is the buoyant force, which was generated due to the difference of pressure. And for instance, we have the mass times gravity, and we can have actually two cases. And in the second case, we can have two cases more. The first case is going to be when both of them, the sum of forces, buoyant minus mass times gravity, has to be equal to 0. This is the static, right? And if we express, for instance, the buoyant force as the density of the fluid, gravity, volume of the object, minus the density, and we can express the mass as the density of the object times gravity times the volume of the object, and this has to be equal to 0. If we cancel common terms, for instance, gravity and volume, we can actually obtain or see that this will happen when the density of the fluid equals to the density of the object, which is submerged. The second case is when, for instance, we have mass times acceleration, and we can have two cases: that the buoyant force is larger than mass times gravity, which means that the acceleration will be upwards, and this will happen, for instance, if we have the density of the fluid, gravity, volume has to be higher to the density of the object, gravity, volume of the object. Both of them are the volume of the object, since it's the volume displaced. And this could actually state that this will happen, for instance, when the density of the fluid is larger to the density of the object, and that's the reason why lower density objects float in higher density fluids. The very same reasoning could be when, for instance, the mass times gravity, or the weight of the object, is larger than the buoyant force. This means that the acceleration will go downwards, and this will happen when the fluid has less density than the object. The object is more dense, and that's the reason why more dense objects will actually tend to go downwards. This is the principle that is working, for instance, in ships, and you might actually try to understand why a very huge ship is floating in water, since it's very, very huge and it should be sunk. But you have to understand that the volume in the buoyant force, density, gravity, volume, the volume is the volume that is displacing the fluid. For instance, this volume is the important one, and that buoyant force, or that has to be equal to the mass times gravity of the ship. And most of the ship is air, and since air is less dense than water, that's the reason why this is floating. Then remember what happens if, for instance, a ship starts to get fluid inside, then it will start to sink, right? That's the reason, because then they are equating the densities of the fluids. In the other case, it was murder. So this tutorial introduced a new force, which is the floating or buoyant force, which is the density of the fluid, the gravity, times the volume displaced by an object which is submerged in a fluid. And of course, when working with forces, we have to take into account that there are many forces, and we have to generate a so-called free body diagram in order to work with this, and then generate the sum of forces, and it could be equal to 0 or equal to mass times acceleration.